My name is Matt Robinson. I'm the technical artist here at Nordeus, and today we're going to talk about what exactly tech art is, a few of the sub-disciplines inside of it. We're also going to go through a few practical examples from my career path in terms of how I've contributed value as a tech artist. And then, as soon as I fix my mic, we'll also go into a few options for tools so that you guys can start creating art at home. So, what is technical art? I have no idea.
Matt? Maybe.
Yeah, it's good? Okay. So, tech art is basically adding algorithmic and programmatic approach techniques to your artistic toolbox. So you've got illustration, you've got sculpting. You're also adding algorithms and programming into that as well. It's basically combining the speed and advantages of technology with the traditional techniques. So inside of tech art, we've got animation and rigging. We've got materials and shaders, procedural content creation, optimization, pipelines, and tools. Now, materials, shaders, procedural content creation, and animation are all disciplines that end up creating content. On the other hand, the others are there to support content creators themselves. In terms of animation and rigging, so on the left, I know Vlada went into this a little bit, so I'll try and just get through it. But on the left, we've got a character in a pose. That comes about because there's a skeleton underneath it. And on the very right, we can see that that skeleton is attached to that mesh. Wherever it's white, you can see that the bone here is influencing how that mesh is going to deform. And what a tech artist is there to do is to help make sure that the right number of influences are in the right places in order to ensure that the mesh deforms in a believable and aesthetically pleasing way. Once we get a mesh bound to a skeleton, we then develop a control system that the animator then uses to actually animate the character. The reason we don't animate the bones directly is because it's often awkward and it's not particularly effective. By adding a control system, we can actually animate multiple bones at the same time, which makes everything go a lot faster and gives the animator more control. Materials and shaders. So a shader, is it not working?
I would help you trying to wait.
Sorry, it's my first day. I'm sorry. So here we've got materials and shaders. So a shader is basically a small program, or sometimes not so small, that's there to define the shape and the color of things. A material takes a shader as well as images and configuration to define a specific shape for a specific thing. Up top, we've got some of Nicola's work. He's our lead artist on Heroic. And the reason I have this up here is because, one, Nicola himself he doesn't call himself a tech artist, but as an artist, he's able to leverage some of the proceduralism of a tool called Substance in order to very quickly, with very little effort, generate an entire range of materials. Down below, on the bottom right, we can see kind of on the left there, what looks like a slow motion, very snappy animation. And then on the right, it's a much more fluid animation. So the reason that's happening is because the shader is able to use some of the information in the purple triangle to interpolate that motion at runtime. So this is an area where instead of having to add a bunch of extra keyframes and image data, we can bake all that down and use that to create a much better effect at a lower runtime cost. So for procedural content creation, the Heroic Art team was prototyping a way of using noise maps and randomness for placement, and even using physics simulation to quickly create a new arena for Heroic. The other approach is to try and sculpt everything by hand, to place all those rocks by hand. As games get more complex, you need more content, and you can't use those old techniques anymore. You have to figure out ways to work smarter and work faster. When we get to optimization, so part of a tech artist's job is to understand what's happening within the game at runtime and help artists translate that information into the constraints that they have to apply to their artwork. And in some of these cases, like in the top left, artists will create very high resolution textures that are great for marketing, they're great for cinematics, but there are times when the asset that they're applied to is actually very far away in the distance, and maybe we don't need all that data. So we can actually create a set of bitmaps that allow us to load only a tiny bit of information and scale that up as necessary, say as that object gets closer. Similar concept applies to meshes. In the bottom right, we've got a mesh at LOD 0, which is level of detail. This is something that you would use when it's like 2 pixels, it's way off in the distance. You're not going to notice that difference, but it helps maintain the runtime performance. So you always get that nice, awesome 60 frames a second gameplay. On the very right is the version that would get loaded in when that's like right in your face. So it's a technique for maintaining quality and performance at the same time. In the top right, we're talking about collision. And oftentimes what you see in the game world is not how the physics engine will see that game world. Oftentimes it needs to be vastly simplified to the point where it's sometimes not even recognizable. Again, this is for performance. It doesn't end up affecting the gameplay, but it does affect performance. Tools and pipelines. So this is where my particular background comes in. Most of what I've done has been around not necessarily creating art, but working with artists in order to help improve their workflows and make it easier for them to do more art and less monkey work. So on the left, we've got a tool that was designed to basically, this was for Elder Scrolls Online. For the character, there are literally thousands and thousands of meshes that go into making up the character customization system that we had. Having an artist having to navigate all of those files with all of the corresponding textures and export data was a nightmare. So this was a way for them to quickly get to something, bring it into a scene, edit it, and then get it back into source control with as minimal fuss as possible. Similar concept in the top right, where we're starting to apply it to things other than just the character customization system. We're looking at applying that to monsters and basically everything else that we would create. And in the bottom right is just some JSON. That is literally like my view into game art most of my day. Just thought you'd like to see that. So from my career path from that tools and pipelines perspective, I got into tech art because I thought I wanted to be an animator. I went to art school because I wanted to work on cinematics that were in Command & Conquer, that were in Warcraft. Thought I was going to work at Pixar. What I found, though, was that I am not a very good animator. I was not going to be able to make a living at it, but I did notice that my fellow animator colleagues were having a really hard time with this thing called rigging. We had taken a class on it, and it turns out that was something that I understood. I understood it a lot more than my colleagues, and I loved the fact that I could automate it. So something that doing by hand would take hours, I could write a script, and I could do it in a few seconds. That totally blew my mind and basically changed my life. From there, I decided that really where my passion lied was in helping creative people solve the problems that are getting in the way of them expressing themselves. So I started out my career working on a game called Golden Axe Beast Rider. It was 2008's worst game of the year, according to GamePro magazine. So started off on a good, yes. For this, I started out as an outsourced intake artist, and what I found that I could do was automate pulling in all of this data from an outsourcer, laying it out in a level, which quickly allowed an art director to come by, take notes, and then I could get that information back out to an outsourcer. From there, once I automated that, that bought me time to work on something else, which was to automate or to provide a set of tools that artists could use to create that collision geometry I was talking about earlier. Before, everybody was doing it by hand. It was a pain. It was costing us money. By creating a tool, it improved our workflow, and artists were able to spend more time working on the actual visual art and less on something that nobody was ever going to see, but had to be there in the first place. So then, unfortunately, Golden Axe and Iron Man did not carry the studio as we thought they would. The studio shut down, and so I had a contract gig at Namco Bandai, where I worked on Splatterhouse. There, I just built a system to help them author all of the limbs so that the player character could pick them up and then proceed to beat other things to death with them, and then pick those limbs up and beat other things. It was good fun. This project also did not do so hot, so I had to move on to Sanzaru games, where Sly Cooper Themes in Time, as well as a few others. This was a really cool game to work on. The gameplay was fantastic, the team was incredible, and this is where I really started to dig into the tools and pipeline stuff. I learned Python while I was at this studio. I used that to parallelize batch processing of things, worked on the export process. Basically, anytime an artist ran into a problem, I was there to help them work through it and then make the pipeline better so that they didn't run into that problem anymore. Sly did not do as well as we thought it was going to do commercially, so Crystal Dynamics, all right. You know, once we get here, I worked on implementing a new rigging system for the character TD that was there, as well as, again, parallelizing some batch processing, introducing automation for source control. Again, this was something that artists shouldn't be doing, but they were doing it, so just automating it freed up time for them to keep working on the stuff that they were actually passionate about. Additionally, this is where I started to work at more of a studio level, taking on something where we had to upgrade Maya from 2011 to 2014, so coordinating with different leads so that it was a smooth rollout. We didn't interrupt any production. It went well. It was around this time that the technical art director who was at Sanzaru had gotten a job at ZeniMax Online Studios working on Elder Scrolls Online. We had worked really well together in the past. He needed a senior tech artist, and so we started chatting, and that led me to ZOS. At ZOS, ESO launched. It was kind of not great at the beginning, but the studio was committed to making it great. So that involved changing our business model, which meant we went from kind of the traditional MMO approach of a subscription to a cosmetics-based microtransaction approach. That meant that we had to drastically ramp up our production of those cosmetic items, which led to the insane amount of production that went into making a pipeline that allowed us to create as many cosmetic items as we possibly could, as quickly as we could, at a quality level that people would actually want to pay money for them. By the time I left, we ended up having, I think, around 8,000 different meshes for just mesh files for cosmetic items. That's not taking into account all of the textures that went with those as well. It's an incredible amount of data, and a lot of it was able to be done because artists had a set of tools that got all of the garbage monkey work out of their way and allowed them to focus on what was actually important. The character customization was so good that people were able to come up with very new and original ideas that are not related to any IP that exists anywhere else in the world. Today, I'm at Techshop, or I'm at Nordeus, where I lead a group called Techshop. I got here about a little over a year ago, and it's been absolutely amazing. The pictures up here are the members of my team as they exist in our HR system. So the guy on the top right is brand new. We haven't gotten a headshot yet. Apparently the guy on the bottom left has been here forever and has never had a headshot, so I got some work to do there. Here at Nordeus, I work across the studio to work with each of our games in order to look at their pipelines and help them make better quality art faster. So here are a few options for tools that you guys can use in trying to figure out if art is for you in the digital sense. I'm sure a bunch of this you already know if you guys are students, so I'll get through it pretty quickly. But one thing I do want to emphasize is that you don't necessarily have to use the stuff that we use here. A lot of it can be kind of expensive. What I would recommend is if this is something that is totally new to you, start out with these, see if it's what you want, and if not, then you haven't invested in anything. But if it is something that you like, then you can start seriously considering upgrading to the big stuff. Oh, wow. My ear is absolutely useless. Right, so it's important not that you're using the tools, but that you are out there actually making things, that you're figuring out your own process. Once you figure that out, you'll be able to work in whatever tool that you need to work in. But if you can demonstrate that you can create quality content, people are going to be willing to train you. So for 2D art, if you've never done 2D art before, I'd recommend GIMP. It stands for New Image Manipulation Program. It's been around for forever. It's totally free. It's open source. That is something you can use to dip your toes in, see if it's for you. It can do photo manipulation. You can draw with it. It's going to get you where you need to go cheaply. If you decide that this is something you like, that you want to spend money on, there's a program called Affinity Photo, and there's Affinity Designer. These are $50 a pop. They're going to get you much closer to something like Photoshop. They're solid programs. And if once you get to that point where you're like, this is my thing, then you can start looking at paying for a Photoshop subscription. For storing this stuff, you're going to be creating a lot of data. I'd recommend a cloud storage, something like Dropbox Plus. It's got this thing called Smart Sync where you can pull files from your computer and put them up in the cloud without having to have them locally. It's going to save you a lot of space in the long run, and it's going to help ensure that you don't lose your work. One of the things that I see a lot of studios struggle with is people not pushing their work up to the central repository. Instead, they keep it locally. I had an issue with this at ZOS where we wanted to use this cool asset for a statue for a collector's edition. So we were going to take this high-res ZBrush model and actually manufacture it into a statue for collector's edition. We had everything in game. We went to look for the source ZBrush file. Turns out the artist didn't check it in. Yeah, just leave it there. Just leave it there. Okay, souvenir. Artist didn't check it in. We then had to pay a principal figure artist for 2 weeks to remake it. So that kind of sucks. Back up your work. 3D art. Blender is going to be the go-to for a cheap 3D program. Once you demonstrate how awesome you are in Blender, you start looking at Max, you can start looking at Maya, ZBrush, all of that good stuff. Again, Dropbox is for backing up your work and for potentially collaborating. Coding. So the reason I put this up here, if you're a tech artist, you're probably going to have to write some scripts. I would recommend Visual Studio Code. It's totally free. It's got a debugger. It's a really, really great code editor. GitHub is sort of like the cloud storage for code. It allows you to push it up there. You can see revisions, history. It's awesome. And then for a language, I'd choose between Python and C#. If you have some experience coding already, C# is probably going to be for you. Otherwise, if you're brand new, Python is going to get you a really, really long way. You can automate a lot of stuff, not just within content creation tools, but just within your own workflow for automatically creating files, renaming stuff. It's just a little bit easier to learn than C#. Plus, once you learn it, you can script Maya with it, you can script 3D Studio Max with it, and I think Houdini uses it, so you're going to be able to get a lot of leverage. On the C# side, if you want to get into game development, Unity is free, and it's based on C#. So between those two languages, you have the entire pipeline. So just to recap real quick, we talked about tech art. We talked that it's a combination of traditional techniques and adding algorithmic and procedural approaches to those. We talked a little bit about my career and how sometimes it doesn't go so great, but you can add value by supporting other creatives. And we talked a little bit about tools. Thanks, y'all.
Matt. So
nobody heard anything, right?
Yeah.
Like
no, it was fine. Let's give one more applause for Matt here. Show some support here. Thank you so much.
Yeah.
Wait, man, there are questions.
Oh, right,
come
right,
on,
right.
I know you want just to leave, but
I said it's my first day.
Yeah, come on, you did it great. So, questions for Matt.
Hey, Matt.
Hello.
Very good presentation.
Thanks.
Question from me is, you said that you learned Python somewhere like during the middle of your career.
Yeah.
Did you have any experience with programming before that?
I had experience with something called MelScript, which is a scripting language built entirely within Maya. The programming experience I had before that was at school. I had one course. So I went to art school. I have a degree in fine arts with animation. I'm not an engineer by education or anything. We had one class that taught us Bash, which is like a Linux shell scripting language, for a few weeks, and then we had another few weeks on Python. Then everything after that was Mel for a few years, and then I got back into Python because at that point Maya had adopted it as a scripting language. In between that, I started reading C# books on the subway going to and from work because the game engine at secret level used C#. It was a proprietary engine. I was just trying to learn as much as I could, and so that's how that came about. I was able to do that because I'm super passionate about programming for some reason. Like, it's this weird balance. I dig art, I dig programming, so yeah, I'm super weird. Does that answer your question?
Yeah, sure. Hence
Cool.
technical art.
Yeah.
And one more question about the LODs. Do you know, is that the reason why all of the textures are made to the power of 2?
That is one of the reasons, yeah. The power of 2 thing, I think, comes from when we load textures into the GPU. It's just much easier for the GPU to deal with a power of 2 texture. So I think it comes down to the GPU requirements.
Okay, thanks.
Sure.
Thank you. Other questions? I have one.
Shoot.
What was the cue for you that you should switch from art towards tech? When did you figure it out? What was the something?
Yeah. So it was when I was at school. I was doing animation, and I had to take this class on rigging. Like, that was just part of the curriculum. And going through the rigging, we started out by doing everything by hand. And this process was very tedious. It was super prone to mistakes. If you messed one thing up, everything afterwards was going to fail, and you wouldn't know until you got there. And then we started learning a little bit about mail scripting and that you could automate this. And so all of a sudden, things that took hours were now taking seconds. And what I also saw was that a lot of people around me within animation were struggling with this. Like, this was something they weren't interested in, but they had to do it in order to get through their final projects. So I started actually doing a bunch of rigging for all of my friends and just found that it was something I was good at, it was something I liked doing, and I was able to help people with it. I was able to help creative people whose stuff I really wanted to see. I wanted to see what these people could make, but they weren't able to fully get it out there because there were technological barriers. So that sort of started to help me realize that what I could do in order to see more cool stuff was to help people make that stuff rather than make it myself.
Yeah, cool. Amazing. One more time, any questions? Cool. Thank you, Matt, so much.
Thank you.